Hi everyone, very good evening and welcome back to Geeks for Geeks practice. Please give me a +1 in the chat if my voice is clearly audible to everyone and everything is working fine. Hi Madbar as well. So guys, please give me a +1 in the chat if everything is working fine. Hi Madbar, hi Rishit as well. Okay. So hi Naikaj as well. So I hope that everything is working fine. Okay. So let us start discussing today yesterday's problem of the day, which was quite interesting and based on the prefix and suffix concept, right? So yeah, in this particular problem, what these people are saying is they are saying that you will be given an array of length n. Okay. So basically, what you will be given is you will be given an array A and that particular array will have n integers, right? Now in this case they are saying you will be given another integer value k. Okay, so you'll be given another integer value k as an input, and your task is to find out the number of cuts such that you can make such that for each cut these two conditions are satisfied. A cut divides the array into two parts. Okay, so a cut should be able to divide the array into two parts, and both the part length should be greater than 0, and the sum of the largest part on the left side and the sum of the smallest part on the right side is greater than equal to k. Okay, so suppose if I divide it here, right? So in that case this will be the left part. Okay, in this case let's say if I divide it like this, okay, and suppose this is the right part of it. Okay, so they are saying that the maximum on the left, suppose I in this part of the left, the maximum value that I'm attaining, right? They are saying that sum of the largest part in the left side plus the sum of the smallest part on the right side. So from this point till this particular point, the minimum part, right? If their sum, if it is greater equal to k, then you will say that okay, it is a proper cut for it, and we have to count this particular cut. So we can do simply count plus plus, because when we are making a point cut at that point, so we can say that it will be counted as a proper cut such that the sum of the maximum we are making a cut such that the sum of the maximum on the left side of the cut plus the sum of the minimum on the right side of the cut is greater than equal to k. Is this part clear to everyone? Please write +1 in the chat, and please hit the like button, guys, if everyone is clear. Please hit the like button if everyone is clear with this much part. Is everyone clear with this much part? What you need to do is you need to divide the array, right? You need to find the number of cuts such that whenever you make a cut, so you can get a left part of the array, you can get a right part of the array, and when you get the left part of the array and the right part of the array, so in the left part whatever is the maximum value, and in the right part whatever is the minimum value, the sum of that should be greater equal to k. Is this part clear to everyone? Then it will be counted as a good cut, you can say, and we have to count all those cuts. Is this part clear to everyone, guys, or not? Please tell me in the chat. You can give me a +1 or write yes in the chat, and then I can proceed further. Okay, you can give me a +1 and hit the like button if you have understood it till now. Okay, so a lot of people are saying clear. What about others? Others can also write clear in the chat. I hope that this point is clear to everybody, right? So in this particular case, if you will see, if the array has been given like this, let us suppose if the array was given like this. What was the array? Suppose the array was n is equal to 3, so you had an array of size 3, and you had k is equal to 3, and you had the array as 1, then you had 2, and then you had 3. Okay, then what we could have done is let's say if I make a cut here, then in that case the minimum on the left, the maximum on the left side is nothing but true, and 2, and the minimum on the right side is what? Is nothing but 3. So the sum of that will be nothing but 5, which is greater equal to k. So this will be marked as one counter. Okay, another. So basically I am saying that 1 2 is one part and 3 as another part, right, as the right part, and the minimum in this part and the maximum the maximum in this part and the minimum in this part. Or what I could have done is I could have divided the array like this, right? I could have 1 here and 2 in 3 if they are here. So the maximum in this part and the minimum in this part, right? So that would be nothing but 1 plus 2. Okay, so that is also greater equal to k, that is greater equal to 3. So again that would be also counted. So that is why for this particular test case we are having the answer as 2. Is this part clear to everyone? Utkarsh Sharma and everybody else, is it clear to everybody, guys? Please let me know in the chat. Is it clear to all of you? If yes, then again, for those who are watching new, they can hit the like button. Is this part clear to everyone? The cut part is clear? Okay, very good. Now, I think that the second test case also looks very similar, right? In this case, if you take this cut, right, and 1 and 2 are left, so the maximum on the left and the minimum on the right. So maximum on the left is 2 and minimum on the right is 3. So the sum would be 5, which is greater or equal to 5. K value is 5 here. Then after that, if you take the maximum on the left, so that is 3, and minimum on the right, so that will be 4. So 3 plus 4 will be 8, which is greater or equal to 5. So again, another counter. And you can see if I take another cut, so the minimum, the maximum on the right left will be 4, and the minimum on the right will be 5. So that is 9, which is greater or equal to 5. So this much point is clear to everyone. Very good. Now in this particular case, now what you can understand is, if you will try to do a brute force, right? Let's say if you are cutting it at a particular point, then you iterate on the left side. Let's say you cut it on the ith point and you iterate on the with a j loop on the left side and another k loop on the right side. Okay, for finding the maximum on the left and minimum on the right side. Okay, then in that case, the overall complexity would be something like order of n square. But what we can do is we can do something better than that. Okay, we can use the concept of prefix and suffix approach, right? If you know, like, see, let me tell you in 1 second. Like, what does it mean when I say prefix of I, right? Prefix of I means nothing but if I talk about the prefix sum of I, right? So in that case, prefix sum of I means sum of all the elements starting from the 0th element till the ith element. Agree with me? Please write +1 in the chat. Sum of all the elements from the 0th element till the ith element. That is what prefix sum is known as, right? So in this case, if I have to find what? If I have to find the minimum, if I'm making a cut at the ith point, so in this case, if I have to find the minimum, right, till the ith point, so I can use what? I can use the prefix minimum. Can we use maxi? You can use it, but it will take more time complexity. I'm telling the most optimal code right here. Okay, so in this case, prefix minimum, if I'm taking, so that will calculate the minimum. Okay, that is going to calculate the minimum of all the values from a of 0, a of 1 till a of I. Is this part clear? Prefix of I is going to tell us the minimum. Is this part clear to everyone? Till now, is it clear? Please tell me. And similarly, if you talk about suffix sum, right? If you please write prefix in the chat if everyone is clear with the prefix thing. If you talk about the suffix sum, right? So what is suffix of I, right? Suffix of I is nothing but it tells you the sum of all the elements from a of I till the end of the array, till the last element of the array, right? It tells you the sum, right? So in this case, what I can do is, if I declare a variable, if I declare an array of prefix suffix of I, and that is going to store, let's say, the minimum for me. Sorry, in the prefix I have to store the maximum. Very sorry for that. So I will write a maximum function here. Okay, yeah, that would be maximum. So yeah, if you will see here, so suffix minimum will store what? It will store the minimum element. Yeah, correct, Naikaj. Maximum on the left side. Yeah. So it will store the minimum element from a of I till the a of n minus 1. Is this much part clear to everyone? Please write yes or no in the chat. Is it clear to everyone? Please hit the like button. Give me a +1 in the chat if you are clear till this point, guys. Okay, suffix of I is going to tell me what? It is going to tell me the minimum on the left side. Okay, minimum out of all the elements starting from a of I till the last element. Okay, so suppose if I want to make a cut at the ith point. Okay, if I try to see what will happen if I do the cut at the ith point, right? If I do a cut at the ith point, and if I want to check whether it is a good cut or not, so what I can check is I can check for prefix of I, right? Prefix of I here is going to tell me the maximum of all the elements from the 0th element till the ith element. Okay, that is what it is going to tell. Plus I am also going to add what? Suffix of I plus 1, because right side will be I plus 1 till the end. So suffix of I plus 1 is going to tell me what? It is going to tell me the minimum of all the elements starting from a of I, starting from a of I plus 1, right? It will start from a of I plus 1 till the end of the array, right? A of n minus 1 kind of thing. So I'm going to find the minimum in that. So that I can do in order of one time. So if it is greater or equal to k, then I will do a counter plus plus. Is this part clear to everyone? We can use max heap approach. Yeah, you could have used the max heap approach and other things also, but prefix and suffix minimum and maximum make more sense. Okay, is this much part clear to everyone? Please write yes or no. Please write +1 in the chat if you are clear till this point. Is everyone clear with this point? Right. So in this case, if I have to take the example of the sample case now, so let's quickly take the example of the second sample test case that has been given to us, right? So let's say the array is 1, then you have 2, okay, then you have 3, then you have 4, okay, then you have 5, right? If you have this particular thing, let's say this is given as the array. So what I will do is I will declare the suffix array here, and so for the suffix array I'll take it from the back. So suffix of n minus 1 will be suffix of a of n minus 1, right? I will write this thing, suffix of n minus 1 is equal to a of n minus 1, right? And I'll keep on taking the minimum. So I will say that minimum is equal to minimum of suffix of I plus 1 comma a of I, right? So here what is the minimum out of 4 and 5? 4. Then here what is the minimum out of 3 and 4? 3. Then here what is the minimum out of 2 and 3? 2. Then here what is the minimum? 1, right? Then after that I will have a prefix variable, okay? And if I'm taking the prefix, so what is the maximum till this point? 1. What is the maximum till this point? 2. What is the maximum till this point? 3. What is the maximum till this point? 4. What is the maximum till this point? 5. Since this is a normal array, so this is a very normal array, 1 2 3 4 5, that is we are having the, that is why we are having the prefix and suffix as same, but it is not necessary that it will happen every time, okay? Please understand this. Now in this case what we will do is, now if I make a cut at this point, right? So in that case this would be the left, okay? So if I make a cut like this, so the left minimum would be what? This. And what is the right minimum? I plus 1. Now in the right side, what is the minimum guy? This guy. So I plus 1th guy will tell me the minimum. So is 1 plus 2, if the k value was what? K value is 5 for this particular test case, right? So tell me guys, is 1 plus 2, because if I make a cut here and rest of the part here, so 1 plus 2, okay, suffix of I plus 1, so is it greater equal to, is it greater equal to k? No, it's not. So in that case I'll not count it as a pair, right? Then I will try to make a cut at the another point. So if I make a cut here in the original array, so the maximum in this, so prefix will tell me the maximum and the minimum will be told by suffix of I plus 1. So 2 plus 3, is it greater equal to k? Is it greater equal to 5? Yes. So I'll make the counter as 1, okay? So the answer becomes, you can say, 1, right? After that I'll move to the next part, okay? And what we will try to do is we'll try to make a cut here. So in this we'll try to find the maximum, so that will be told by the suffix, and the minimum will be suffix of I plus 1. So 3 plus 4, it is greater equal to 5, right? So in that case I'll consider it, and the answer will be marked as 2, answer plus plus here, right? And then after that what we will do is we'll make a cut here, and then in this case if I make a cut here, so prefix is going to tell me the minimum, maximum, right? Maximum, so it will be 4, and the suffix will tell me the minimum, so it will be 5. So 4 plus 5, again it is greater equal to 5, so the answer will again be counted, and you can see I'm having 3 as the answer. Please write 3 in the chat if this part is clear to everyone. Okay, so I'm always checking for the prefix plus suffix of I plus 1. Okay, prefix till the ith guy, prefix maximum till the ith guy, and the suffix minimum from I plus 1, because it has to tell me this thing. Is it clear to everyone? Please write yes in the chat, and please make sure to hit the like button if you are clear till this point. So please make sure to hit the like button. Okay, so that is how we are doing it. Okay, so this much point is, I think, clear to everyone. So we iterate from, yeah, we iterate till the second last element, because if I'm checking for I plus 1, so the last element will not be available. Okay, so what we can do here is we can simply declare a suffix array. Okay, let's say I will name it as suffix array, and initially I'll mark the size as n. Then what I will do is I'll say that suffix of n minus 1, okay, is equal to what? It's equal to nothing but a of n minus 1, right? That is what is going to happen. After this particular point, what I will do is I'll start iterating from the back side. So I start from what? I start from n minus 2, I is greater equal to 0, and then I'll do an I minus minus. And what will the suffix store? It will always store the minimum. So suffix of I is equal to minimum of suffix of I, right? Suffix of I plus 1, comma, what? Comma the A of I. So I'm always going to take the minimum in the suffix part, okay? And then after that, I can take an array, or I can just take a normal variable also. So since I am not, since I'm just iterating and I don't want to increase more space, so I will just take a normal prefix array, okay? Initially I can mark the prefix as 0, right? And then what we will do is we'll say that, okay, int I is going to start from 0, I is lesser than, let's say, n minus 1, then I will do an I plus plus here, okay? Because I'm not going to iterate for the last element, because I'm going to check for prefix of I and suffix of I plus 1. So I'll say that, okay, prefix is equal to maximum of prefix that I've seen so far, comma, a of I, right? So I'm going to find the maximum of prefix value till the ith index, and if it happens that the prefix of till the ith there plus the suffix of I plus 1. So if the maximum in the left side, that is prefix, that is told by prefix, and the minimum in the right side, that is told by suffix from I plus 1 till the end, if that sum is greater equal to if it is greater equal to k, right? So in that case, if it is greater equal to k, then what we will do is we are going to do an answer plus plus right here. Okay, that is what I'm going to do. So in this case, I can initially maybe mark an answer variable initially as 0, right? And then what we will do is at the end we will just return the answer right here. Okay, I think this should work fine. Let me just try and test this code to see if it is working or not. Okay, so what is the error? Okay, capital K I should use. Let's try and submit it now. Let's see what happens here. Okay, so it does seem to work on the samples and gets accepted. Is this part clear to everyone? Right, guys? Is it clear to everyone? The code gets accepted, right? So in this case, what we are using is we are using the prefix and suffix approach, right? So Madbar says that he is very much clear with this, right? So let me just quickly summarize the rest of the things as well. If you will see the space complexity, so I'm just using an extra suffix array. So space complexity is order of n, and if you talk about the time complexity of my code, na, so it will be what? It will be nothing but order of n for iterating for the suffix and plus another order of n for iterating for the prefix as well as the resultant answer. So the overall complexity is order of n itself. So space complexity is order of n and time complexity is order of n, and the approach uses prefix maximum and suffix minimum, right? Suffix minimum. This can be asked in some companies as an easy question or the very first question. Now tell me if you are clear with this or not. If you are clear with this, so please hit the like button. And Utkarsh is also asking something. Let me check what he's saying. Utkarsh is saying, can we iterate that suffix part properly without mistakes? Yes, I have iterated in that part without any mistakes, Utkarsh. What else do you want in this part? Like I have not made any mistakes here. Okay, so let me just paste this link here. Is it clear to everyone? Please write +1 in the chat, everyone, and then I'll simply share this code with all of you. Okay, very good. Okay, so yeah, let me share it with you. Okay, so I think the code has also been shared, but there's some issue. Okay, let me just verify this. Okay. So is the problem clear to everyone? Please write clear in the chat, guys, if everyone is clear with it, and then I will end this stream. Before ending the stream, one more thing that I wanted to tell you, right? We have solved today's problem. Make sure to solve yesterday's problem of the day. Make sure to solve today's problem of the day as well, right? And before ending, I will like to tell you about uh, mastering CP. BFD, right? Just give me a second. I'll just open this particular course. So there's a competitive programming course by Geeks for Geeks. Okay, so you can see Siddharth Hazra is there in the introduction of this video. He is software engineer at Geeks for Geeks. Contest con lega speak. I think Siddharth will be taking the contest if I'm not wrong. Okay, so you can see 60 plus hours of recorded lecture, 100 plus problems, easy, medium, and hard for competitive programming are there. Contest for every part, 50 plus live session throughout the year will be there for you. Internship opportunity, live doubt support, 24/7 doubt assistant, and pre-recorded videos plus the live problem solving for the contest will be there this time. Okay, if you want to see the syllabus, so initially we will be teaching you about time complexity, space complexity, DSA part 1, part 2, part 3, in which we will be telling you about the arrays, matrices, recursion, hashing, string searching and sorting. After that, stacks, queues, backtracking and recursion. Then we will move forward to dynamic programming, tries, and the harder topics, disjoint, set, union. Then in the first week, you will be taught about basic number theory part 1, part 2, part 3. All these part are pre-recorded, and similarly, you can see recursion will be there. Divide and conquer will be there, stacks and queues is there, trees is there, greedy is there, and the contest is also there. Dynamic programming basic, knapsack, 2D DP and combinatorics DP, and DP on strings, matrix chain multiplication is there in DP basics. And in DP advanced you have the range DP, you have the bitmask DP, you have the probability DP, and the digit DP is also there. Then in the graphs you have everything covered, right, starting from the BFS DFS till the very ending. And then you have the strings, right? And after that you have the range sum queries, and you can see the mentors. Sandeep Jan sir is the mentor, then Siddharth Hazra another mentor, then Anil sir who is working at Google, Pawan sir is working at this bank, then after that Ashutosh sir is working at Microsoft. I'll be taking the live classes, live contest kind of classes, so I'm the mentor for this course. And Sachin Bisht is SD1 at Tarana Wireless. Okay, So this is it, and you can check it in the section. What are you saying, Utkarsh? With the help of heap, can we reduce time complexity? No, the heap complexity will be kind of n log n in nature. So Utkarsh, you cannot reduce the time complexity. It will be n log n. So that is why I prefer using this approach. Okay, Utkarsh. So I hope that everyone has understood it. In case if you have understood, so please make sure to hit the like button. Okay, please before this video ends. So please make sure to give me a +1 in the chat. Okay, make sure to hit the like button, and also make sure to comment down after the video is over. If you have understood, then make sure to comment understood, and subscribe the channel if you haven't already. Thanks a lot, guys, for watching for today's video. Is this course helpful for placement or not? It is helpful for the online assessment, and you can say for placements as well. Okay, thanks a lot, Madbar. Thanks a lot, Rishit. Thanks a lot, Utkarsh, and thank you everyone else. I'll see you with another problem of the day in the next week. Till then, good night, take care, and keep coding, guys. Thanks a lot, everyone, for joining, and thank you, Madbar, Rishit, as always. Thanks a lot, everyone.